Clean Air Tower is situated in Binhai, a city in Tianjin. It is one of China's many overnight cities where an entire city of skyscrapers is built simultaneously, all in a matter of years. Due to the construction materials and power generation in these cities, the resultant air quality is terrible. In fact, the air quality in China is one of the greatest risks to health facing the country today. Currently, China burns more coal than the rest of the world put together. This creates, among other toxic chemicals, PM 2.5, a particle 2.5 microns in diameter. PM 2.5 is capable of entering a person's bloodstream through their lungs, causing cancer. 1,200 people died prematurely in 2011 from PM 2.5 exposure in Tianjin alone. This equates to an economic loss of $152 million. To put this into perspective, the average European city has 30 micrograms of PM 2.5 per cubic meter of air. Tianjin often has over 350 micrograms per cubic meter, especially in winter, when the air is drier. Last year, Beijing recorded 755 micrograms. In fact, only 1/3 of Chinese cities meet their own air quality regulations. The air people breathe is endangering the lives of an increasing Chinese urban population. This led me to design a building that can provide clean, filtered air not only for the residents and workers inside the building, but to give clean air to the city around it too. To do this, I researched various existing systems of air filtration. I chose to employ industry-standard machines that filter the exhaust air in factories and are proven to be effective. 2 processes are used in the tower, one for internal air, one for cleaning the city's air. All of the building's processes are located in the core, which includes elevators and stairs, all plant area and air filtration systems, and a solar chimney. The floor area of the building surrounds the core on the north side, leaving the solar chimney open to solar gain from the south. Inside the building, Venturi scrubbers filter the air and work by bubbling air through water. They were chosen for their efficiency in removing a minimum of 95% of PM 2.5 and the fact they disassociate other toxic gases from the air. First, toxic air is taken in from outside. It is then bubbled through towers of water, removing PM 2.5, dust, and other dangerous chemicals. Then, the clean air is distributed by the HVAC system to all internal spaces in the building. Clean air provided for the city is filtered by electrostatic precipitators. They sit inside the solar chimney, which has a constant flow of air rising through the tower by solar-assisted stack effect. The toxic air is first ionized by a mesh. The particles in the air become positively charged and stick to an oppositely charged plate. Here, the PM 2.5 particles can be collected and even reused, as they are almost completely carbon. This process alone provides 8.5 million cubic meters of clean air per year. Enough air for 1 square kilometer of the city. The water from the Venturi scrubbers retains the pollutants removed from the air and is released into a reed bed at the base of the tower. The reeds filter the water, which can then be returned to the river. As the air rises through the chimney by stack effect, it is accelerated by solar gains, reaching a simulated speed of 8 to 10 meters per second. At the top of the tower, the air drives a turbine array that provides enough power to the air filtration systems. At ground level, other than reed beds, there is car parking, service access, a conference center, shops, and an atrium positioned below the solar chimney with a full view of the machinery in the core above. Above the ground level, the tower is constructed of modules. The lower modules consist of office space. This is open plan as standard and fully glazed both to the outside of the building and to the inside of the core, allowing views of the machinery, elevator tracks, and turbines. The residential modules above have the same internal views of the core, and each unit has multiple glazed balconies. The units have 2 bedrooms to suit either 2 working professionals or a couple with a child, as are the most common situations in China. Each module is punctuated with a sky garden that provides a much-needed clean air, green space environment. These areas provide space for the residents and public to enjoy healthy, filtered air and have room for exercise and sports, activities that are often prohibited in schools due to the dangers of air toxicity. The Chinese community utilizes outside green space on a daily basis to play games, have discussions, even for square dancing. Providing green space where people don't have to fear for their children's health will act as a hub of community, not only for the tower, but for the surrounding area. At the peak of the tower, with the turbine array, is an experiential viewing platform where visitors can see all the way down the solar chimney, including the machinery, the activity, and views of the surrounding city. This viewing deck, sitting above 5 modules, reaches a height of 228 meters, creating a strong profile against the riverbank on which it sits. Vertical access involves 4 shuttle elevators that will link the sky gardens between each module. From there, 6 local elevators travel to each floor within that module. Each module is supported by a megastructure that sits along the perimeter of the floor slab. This megastructure replaces the core as a source of shear strength, allowing the core to be lightweight and transparent to maximize solar gain to the chimney. The number of modules stacked up is determined by the toxicity of the air and the office and residential needs of the city. When the air quality is safe and stabilized, some of the tower's modules will be deconstructed and could even be sold to other cities in China or other countries in need of air filtration. In fact, many of China's closest neighbors have air pollution as high as Binhai. This creates a plan for the life cycle of the tower. In 2016, this tower would consist of 3 modules. In 2020, as Binhai gains population, 2 additional residential towers would be constructed. In 2035, when air toxicity is at its worst due to increased coal usage, additional clean air towers would be built in Binhai. In 2050, when Binhai's air is clean and healthy, towers are partially deconstructed and relocated to other cities in China or the world.